So, dear students, in our last video on the numerical solution on electromagnetic induction, we have solved some numerical problems. Now, in the second video, let us solve some more numerical problems related to electromagnetic induction. First numerical is a plain circular coil has 200 turns and its radius is 0.1 meter. It is connected to a battery. After switching on the circuit, a current of 2 ampere is set up in the coil. Calculate the energy stored in the coil. Solution: self-inductance of plain circular coil is given as L is equal to mu naught N square A upon 2R. This becomes mu naught N square. A means area of each turn, pi R square upon 2R. Here 0.1 meter, N is 200 turns, mu naught is 4 pi into 10 to minus 7 Henry per meter. Therefore, L will give us 4 pi into 10 to minus 7. N is 200 square, and 2 pi 1 R cancels out into R. R is 0.1 upon 2, which gives as 7.89 into 10 to minus 10, 7.89 into 10 to power minus 3 Henry. Therefore, energy stored will be equal to half L into I square. I is given to be 2 ampere. So, 1 by 2 L 7.89 into 10 to minus 3 into 2 square, which gives 1.57 into 10 to minus 2 joules. Which is nearly 1.6 into 10 to minus 2 joules. Second question, find the EMF induced in a straight conductor of length 25 cm on the armature of a dynamo and 20 cm from the axis when the conductor is moving in the uniform magnetic field of 0.5 Tesla. The armature is rotating at 1000 revolution per minute. Solution: here given length of conductor is 25 cm, which is 0.25 meter. Uniform magnetic field B is 0.5 Tesla. The frequency of armature is 1000 revolution per minute, which is 1000 upon 60 revolution per second, which gives 16.67 revolution per second or hertz. Radius of armature is 12 cm, which is 0.12 meter. We have to find the EMF induced. Now, EMF induced will be is given by E is equal to B L into V. This will be B L and V is equal to R omega, because V is equal to R omega and omega is equal to 2 pi F. So, B L into R into 2 pi into F. B is 0.5, L is 0.25, R is 0.12 and into 2 pi into 16.67, which gives induced EMF as 1.57 volts. Question number 3. A rectangular coil of 100 turns has dimensions 15 into 10 cm square. It is rotated at 300 revolution per minute in the uniform magnetic field of flux density 0.6 Tesla. Calculate the maximum EMF induced in it. Solution. Maximum EMF induced in dynamo is given by E maximum is equal to omega n A B, which is 2 pi F n A B. Here A is 15 into 10 cm square, which is 150 cm square or 150 into 10 to minus 4 meter square. N is 100 turns. Magnetic field of flux density 0.6 Tesla. F is, frequency F is 300 revolution per minute, which is 300 revolution upon 60 second, means 5 hertz. So, E maximum बराबर 2 pi into F5 into N 100 into A 150 into 10 to minus 4 into 0.6, which gives next question number 4. A long solenoid with 1500 turns per cm has a small loop of area 2 cm square placed inside normal to the axis of the solenoid. If the current carried by the solenoid changes steadily from 2 ampere to 4 ampere in 0.1 seconds, what is the induced EMF in the solenoid? Solution. Here given number of turns per unit length small n is equal to turns per unit length. This is 15 turns per cm, which is 1500 turns per meter. Area of each turn is 2 cm square, which is 2 into 10 to minus 4 meter square. Next, di upon dt, rate of change of current is di upon dt, 4 minus 2 ampere upon 0.1 second, means 2 upon 0.1 means 20 ampere per second. We have to find the EMF induced. So, EMF induced will be equal to or back EMF induced is numerically equal to d phi upon dt, or this is minus d phi upon dt. Minus sign is due to Lenz's law, gives the direction of induced EMF. So, we can say magnitude E m or E back is equal to E back is equal to d phi upon dt. This is d upon dt, phi is A into B. This can be written as A into dB by dt, because A is constant. So, A into d upon dt, B is mu naught n I. Mu naught n is constant, may be taken out. So, mu naught A, this is mu naught A n di upon dt. Mu naught is 4 pi into 10 to minus 7. A is 2 cm square, means 2 into 10 to minus 4. N is 1500 and di upon dt is 20. So, EMF will have value 7.5 into 7.5 into 10 to minus 6 volts. Now, question number 5. Two plane coils having number of turns 1000 and 2000 and radii 5 cm and 10 cm respectively are placed coaxially in the same plane. Coaxially in the same plane. Calculate their mutual inductance. Solution. Mutual inductance has magnitude d phi upon dt. d phi upon dt. This is d upon dt or mutual inductance may be given by the relation its magnitude d phi 2 upon d I1 means rate of change of magnetic flux in secondary coil to the change of current in primary coil ratio. So, this is N2A2B1 N2A2B1 minus 0 upon I1 minus 0. This is N2A2B1 is mu naught N1 I1 upon 2 R1 upon this I1 cancels out. So, M is equal to mu naught N1 N2 A2 upon 2 R1. Now, values are given. N1 is equal to 1000 turns, N2 is equal to 2000 turns, R1 is equal to 5 cm means 0.05 meter and R2 is 10 cm which is 0.1 meter. Therefore, mutual inductance will be mu naught means 4 pi into 10 to minus 7 N1 1000 N2 2000 A2 means pi R2 square. So, pi into R2 0.1 square upon 2 R1 means 0.05 which gives mutual inductance as 0.789 Henry which is nearly equal to 0.79 Henry. Next question number 6. Question is, when a wheel with metal spokes of 1.2 meter length is rotated in a uniform magnetic field of flux density 5 into 10 to minus 5 Tesla normal to the plane of the wheel and EMF of 10 to minus 2 volt is induced between the rim and axle. Find the rate of rotation of wheel. Solution here given. R is radius of wheel, 1.2 meter. Perpendicular magnetic field 5 into 10 to minus 5 Tesla. This is magnetic field normal to the plane of coil. Plane of wheel. Rate of rotation means frequency is what? If induced EMF is 10 to minus 2 volt. This is EMF induced between the rim and axle. Now solution. We know that when a circular wheel of surface area A is rotated in perpendicular magnetic field, then EMF induced is given by when a wheel of surface area A is rotated in perpendicular magnetic field, then EMF induced is given by E is equal to A B into F. So here A is pi r square into B into F. F will be equal to E divided by pi r square into B, 10 to minus 2 upon pi r means 1.2 square into F, into B, 5 into 10 to minus 5, which gives 44.43 revolution per second. Next question number 7. A circular metal disc of area 3 into 10 to minus 3 meter square is rotated at 50 revolution per second about an axis through its center perpendicular to its plane. The disc is in the uniform magnetic field of flux density 5 into 10 to minus 3 Tesla in the direction of the axle. Find the induced EMF. Solution. Induced EMF in a circular disc rotated in the perpendicular magnetic field is given by E is equal to A B into F. Here A is 3 into 10 to minus 3, B is 5 into 10 to minus 5, and F is 50. So we get induced EMF as 75 into 10 to minus 5 volts. Question number 8. A transformer has 500 turns in primary and 100 turns in secondary coil. What is the output voltage if the input voltage is 4000 volts? If the transformer is 100% efficient, what primary current is required to get 2000 watts from secondary? Now, solution here given for a transformer. Number of turns in primary 500 turns. Number of turns in secondary 100 turns. EMF applied in primary is 4000 volts. Efficiency 100% means 100 upon 101 first. E secondary is what? That is output voltage and second one IP is what? Primary current to get P secondary as 2000 watts, means output power ethic. Yeah? Next solution. First one, for transformer NP upon NS is equal to EP upon ES. Therefore, ES will be equal to EP NS upon NP. Values are known. EP is 4000, NS is 100, NP is 500. So we get 800 volts. Second part. Now second part, efficiency is equal to output voltage upon input voltage, that is PS upon P primary. Efficiency is 1 is equal to P secondary is 2000 watt upon P primary is equal to primary EMF into primary current, because power is equal to current into voltage. Therefore, I primary will be equal to 2000 upon EP, 2000 upon 4000, which is 0.5 ampere. Next question, number 9. A step down transformer transforms a supply line voltage to 20 volts in 100 volts. Primary coil has 500 turns. The efficiency is 80% and power transmitted by the transformer is 80 kilowatt. Find the number of turns in secondary coil and the power transmitted. Solution here given for step down transformer. Primary EMF is 220 volt. Secondary EMF is 100 volt. Number of turns in primary is 500 turns. Efficiency is 80%, means 80 upon 100 means 0.8. And power transmitted means P output or P secondary is 80 kilowatt. Kilo means 1000, 80 into 10 power 3 watt. First, we have to find number of turns in secondary and second power supplied, means power supplied through the primary coil. Now, first EP upon ES is equal to NP upon NS, which gives NS as NP ES divided by EP. NS will be equal to number of turns in primary 500, ES 100, EP 220. So we get 227.27 turns. 227.27 turns in primary. Now second part, efficiency is defined as the ratio of P secondary and P primary. Therefore, 0.8 बराबर इज इक्वल टू 80 किलोवाट अपन P प्राइमरी which gives, therefore P primary will be equal to 80 kilowatt divided by 0.8 which will be 100 kilowatt.